Hey everybody. Okay, let's get cracking. So I'm going to be on here for about an hour. So let's get going. So this is going to be day 3 of the algebra review, and of course, if you've missed day 1 and day 2, you can go see them on my channel somewhere. They're out there. Okay, so yeah, I'm going to go a little bit faster. So I know I saw a couple people here. Good old Queen Bee, welcome back, Queen Bee. It is very nice to see you. And then I think Phaser. I think I saw Phaser somewhere. Phaser Beams is there. So I know yesterday we started doing right. We finished up with some of these inequality questions that we were looking at, and I think we finished on number 25. And we talked about on that one how to solve a rational equation, what we want to do. Oh no, is my, okay. Of course. So what we would like to do, oh no, let me try to restart this for a second. Notability is acting weird on me. I apologize. What we want to do right is, oh no, am I still on music videos? We don't want that, do we? I don't think so. All right, so what we want to do for rational equations is we want to make one side of the equation equal to 0 and get a single fraction on the other. So we talked about quite a bit of those. Do you all want me to do more of those rational equations? If not, I think I'm going to jump into the absolute value inequalities and do those real quick. So my apologies here. Okay, so let's see here. This is the problem. So sorry. All right, I think we're okay. Okay, I think we're good. So let's do this. Oh man, sorry about that. So I'm going to jump into the inequalities. Let's start going here. And that still does not want to work for me. Okay, oh my goodness, okay, 25. You all are so patient. Or excuse me, 26. The absolute value of x minus 4 less than 7. You'll see absolute value equations a couple times when you, yes, this is live, sorry, Miguel. So you will see absolute value equations periodically, and at least in a calculus class. Again, we talk about this usually in terms of distance. You won't see the a large amount. And again, to solve this absolute value equation, this absolute value inequality, we need to be careful about the type of inequality that we have. So notice we have the absolute value less than something, in this case less than 7. Well, if you think about it, again, if you think about a number line, the absolute value of what numbers are less than 7? Well, I think we could take anything between -7 and +7, right? The absolute value of any of those numbers would be less than 7. So in that case, that tells me, well, that this quantity, x minus 4, it needs to be less than 7, and it's got to be greater than -7. So you end up getting this compound inequality, is all that happens. And to solve this, we can simply add 4 to, sort of all three parts. -7 plus 4 is going to be -3, less than x, and then 7 plus 4 is going to be 11, is the idea in this case. And notice we can interpret this absolute value of x minus 4 Notice the interpretation of that is, and this is kind of the important thing. I think sometimes people don't point this out or they just don't really think about it. I know I didn't at first. What does this absolute value represent? This absolute value gives all numbers, that are within 7 units of the number 4. That's what we're doing in this case, right? The absolute value of x minus 4 less than 7, it's giving us all numbers that are within 7 units of the number 4. So that's what that absolute value represents. Okay, so let's go on to the next one. So the next absolute value, which is 27, and of course, please stop me if you have questions. The absolute value of x plus 5 greater than 8. Well, notice again, we've got a different type of inequality in this case. Before we had less than. Well, now we've got greater than. And we have to be careful again about the way that we go about setting this up. So we can't just sort of mindlessly, create some inequalities. So in this case, again, I'm thinking the absolute value of what numbers is going to be something larger than 8. Well, certainly something larger than 8 would work. 9, 10, 11, 12, the absolute value of those are all larger than 8. So if I get numbers in that set, that's good. Well, also if I get numbers less than -8, I think I would be in business, right? The absolute value of -9 is 9. That's greater than 8. Likewise, -10, -11, and -12, so on and so forth. So we need to solve 2 inequalities. We want x plus 5 to be less than -8. That's going to sort of give us this, well, not sort of, it is going to give us that first interval of numbers. And then we also have to solve the inequality x plus 5 simply greater than 8. And that's going to give us this second little set of numbers. Well, we can subtract 5 from the first one. -8 minus 5 is going to be -13. And then x plus 5 greater than 8. If we subtract 5 from both sides, we'll just simply get that x has to be, whoops, I was thinking it, x has to be greater than 3. So in this case, we could write our solution set. We could say that's from -infinity up to -13. So anything in that interval will work. Or anything that is 3 or larger will also work. So that will be our interval. Let's see. Okay, so I'm going to ask, should I do any more rational inequalities? Or should I just go on to the linear stuff, which is next? Or jump on to the next stuff. So if not, if I don't get a good vote here, I'll probably just jump on. But you all tell me if you want to see an extra one. Not really. So not really any rational. Okay, then I'm going to keep on and I'm going to jump on to the linear stuff. And I think we should go. All right, so there's one vote. Okay, perfect. That sounds good. Okay, well, let's keep going on. And I think we can go through the linear stuff quickly. There's honestly some other topics I'm going to throw in here. So as we kind of go through this, I was looking at this review, and again, it was made for calculus students, but there are some other things that I want to talk about. Okay, so let's talk about the distance formula. Maybe I'll do one of these and let you do the other one. The only thing that's different between 30 and 31 is the fractions, right? The only thing that gets more miserable is dealing with those fractions. People, I don't care sort of what math class they're in, a lot of people still get nervous about fractions. So if you want me to do the second one as well, by all means, let me know. Okay, so you may recall the distance between 2 points, x sub 1, y sub 1, and we'll call the other one, x sub 2, y sub 2, and I'll draw a little picture for this. The distance between those 2 points, so I've got some point here, it's got some x coordinate and some y coordinate. So generically, I'll label that little x1, little y1, and I don't know, I've got some other random point here, and it doesn't matter how I draw these points generically, it's just to sort of see a picture. if we want to find that distance, right, we're trying to find that length between those 2 points. And to compute the distance between those 2 points, we take the square root of, we take the difference between the x coordinates and we square it. And then we take the difference between the y coordinates, we square those, we add those 2 values together, and then we just take the square root of that. So I'm not sure what you're saying. Another one there. So okay, so the distance formula, and all that's coming from is the Pythagorean theorem, right? So the Pythagorean theorem, A, B, C. If you have a right triangle, right, a squared plus b squared equals c squared. That's just the Pythagorean theorem. Or if we take the square root of both sides, we'll get that c equals the square root of a squared plus b squared. So you could think about this as being c, this length as being a, this length as being b. But notice to get that length a, it's going to be the difference of the x coordinates, x2 minus x1. That length of b is going to be the distance of the y coordinates, y2 minus y1. So if we substitute all of those 2 values in, we're simply getting this formula is the idea, right? And instead of c, let's call it d for distance. So if you forget the distance formula, this is the moral of the story. If you forget the distance formula for 2 points, it's Pythagorean theorem, as long as you remember that. Okay, so let's just do one real quick. This shouldn't be terrible. But again, it's just one of these little nitpicky things that you'll need to know at some point. Certainly circles and will crop up in a lot of classes. You want to be able to find distances, to find diameters and radii, and also too, just in word problems, a lot of word problems, you're finding the distance between 2 things. In particular, you're going to be finding the rate at which the distance between 2 things changes. Okay, so let me try to get my formula in there. So again, x1, y1, x2, y2. So it says take the difference. So 4 minus 1 squared. So 4 minus 1, again, I square it. And then I do the same thing with the y coordinates. I guess I shouldn't have used 1, 1. Maybe I should have used something different. 5 minus 1 squared. Okay, so I'm doing, again, 5 minus 1. Well, that's going to be 3 squared plus 4 squared. That's going to be 25. Excuse me, the square root of 25, which is just going to be equal to 5. So no big deal, I think. At least I hope not. It's just a formula to remember. So I'm going to skip, maybe we can skip number 31. It's the same, but fractions. And again, please tell me in the comments. Keep going, slow down, whatever, So 32, we want to find the midpoint between those same points. So we want to find the midpoint between the points 1, 1 and 4, 5. And again, this isn't super important. You'll see some questions periodically. It's just the circles. And it's not like you need to memorize this formula. Yes, that's correct. So the hypotenuse is 5, queen bee, and that means that distance between those 2, yes, that length between those 2 points that we had, my 1, 1 and my 4, 5, that length is going to be 5. Or in terms of the picture, yes, the hypotenuse is going to be length 5. That's exactly correct. That is exactly correct. So a formula to remember, but again, it's from the Pythagorean theorem. So midpoint, a midpoint is just an average, if you think about it, right? If you made a 50 on one test, oh no, and you made 100 on the second test, right? If you made a 50 on one test and you made a 100 on the other test, and they said, what's your average? Well, to get your average, right, we would add those 2 values together, and we would divide by 2, which would be 75. Right, 75 is the midpoint between those 2 values, 50 and 100. Well, guess what? To get the midpoint between 2 points, we just do the same thing. We'll take the x coordinates, and we'll add those together, and then we divide by 2. So you're just finding that average. So let me even go ahead and do that. And there's more to the formula. But that says we would take 1 plus 4 divided by 2, and 1 plus 4 divided by 2, that's 5 halves, or 2.5. And if you compare 1 and 4, all right, there's 1 and there's 4, yeah, 2.5 would be the midpoint. It's right there in the middle. So that seems reasonable. And then you just do the same thing with the y-coordinates. So again, nothing crazy. So what were the y-coordinates? There we had 5 plus 1. And again, we have to divide by 2. So that's 6 divided by 2, or simply 3. And again, 3 is in between. It's exactly in the middle between 1 and 5. So that's going to be the midpoint. So for example, maybe somebody says, you're given 2 points, and maybe those are on the diameter of a circle, and you're asked to find the equation of the circle. Well, you may remember to find the equation of a circle, you need to find the center, but the center, hey, that's the midpoint. So if I know those 2 points, I know how to find the midpoint. To also find the equation of a circle, we need the radius. But now I know the midpoint, I know one of the points on the diameter, I can use the distance formula, we got the radius, boom. I now know, I would now know the equation of my circle by computing midpoints and distances, and again, knowing the formula for a circle. So that's kind of the idea, I think, where it might tie in for some of you. Again, going in calculus. Okay, slopes, you may recall slopes. So slope of a line, that's just, we say change in y over change in x. So change in y over change in x. And recall that this little triangle sign, that little delta, the way you read that mathematically, we say it is the change in. So if you see that little symbol, it means something's changing, is what it has to do with. And I shouldn't write a little comma. I'm going to put an equal sign. That's the same thing. Well, to get the change in y, we take the difference in the y-coordinates. And to get the change in the x, we take the difference in the x-coordinates. And likewise, if we have this from a graph, you may see this described as rise over run. You may remember let's do slope-intercept formula first. We'll talk about point-slope form too. Slope-intercept form of a line, because we'll talk about that in just a second anyway. And that's going to be y equals mx plus b. Recall that m is the slope. So the slope usually, almost always, is denoted by the letter m. And this value of b, that's going to be the value of the y-intercept, which is wherever, it's going to be the y-coordinate of where your line crosses the y-axis. Okay, so all of these equivalent ways of thinking about slope. And they're all useful, so you want to know, you want to do them all. Okay, easy peasy. I think I used the same points again, or did I not? Find the slope through, this is 34, find the slope through P and Q. So here I used 1 to 5 and 4 to 9. So let me draw a rough graph. I'm not going to label the coordinates. Well, okay, there's 1, I guess I will. There's 5. So there's one of my points, 1, 5. We'll just put 4 over here, and we'll put 9 up here. So that's the point 4, 9. That's the point, we said 1, 5. And let me put in here, there's 2, there's 3, 6, 7, 8. So 6, 7, 8. So if we wanted to find the slope of that line, so the slope m, we're trying to figure out the slope of that line. Well, again, we could do the formula. We could take the change in y over the change in x. Okay, well, let's do that. That's not too bad. So the change in y, that would be my y-coordinate, the difference of the y-coordinates. So 9 minus 5. And then the change in x, which is going to be 4 minus 1. 4 minus 1. And in the numerator, I'm going to get 9 minus 5, which is 4. And in the denominator, I'll get 3. And that is going to be the slope. That's going to be the slope of my line, which is going to be equal to 5. Notice we could also count if we had these points. We could use this rise over run idea. And again, I'm just counting. So the rise, you think, how much do I go up or down? If you go up, it's a positive. If you go down, it's a negative. And then the run is how far you go left or right. If you go left, it's negative. If you go right, it's positive. Well, if I look at, I'm reading my graph left to right. So if I start at this point 1, 5, the change in y, well, I'm going to go to 6, to 7, to 8, to 9. So I go up 1, 2, 3, 4. That's the change in y. That's what we got. So now I'm sitting up here. And then the change in x, I would go 1, 2, 3, again, to get to that new point, which is the change in x. So you can certainly count these if you have a nice graph. The problem is, obviously, if you don't, for example, have nice whole numbers, 1, 5 and 4, 9, you don't want to be counting points, right? You want to use the formula. So, but certainly you want to remember all of these things. And just to remind you again, so a couple quick questions, and again, please help me out here because I feel like I'm talking to myself a little bit, which is okay because that's how it goes. That's how us boring instructors also sound. So my graph looks a little wonky there. Suppose that's a nice pretty x and y axis. If your line is moving up as you go left to right, what can we say about the slope? Can we say anything about it? Not a lot you can say, but there is something super important you can say. Anything? Positive slope. That's it. Yes. So if the line is pointing up, we know it has a positive slope. Likewise, if the line is pointing down, we say it has a negative slope. So there's two lines. What if the line is horizontal? I mean, if it's negative going down, if it's positive where it goes up, if it's horizontal, so let's pretend that this line is horizontal. Horizontal. We would say that has a slope of what? And let me see your question here. Where the line crosses the y-axis is the y-intercept. Yes, absolutely. And where the line crosses the x-axis is the x-intercept. It doesn't matter that it is infinite to the other side too. Yes, Miguel, it does. Thank you. I'm being sloppy. Yes, I'm being very sloppy. It absolutely. I should put an arrow on it. A lot of textbooks they don't even leave the arrows. They'll just have a they won't even put the arrows. They'll just have a line and it's understood that it goes on. But yes, if I put an arrow on the left, I should put one on the right. So is it because of x and y being to the right? I should put that on there as well. Yeah, it just indicates that it keeps going on forever, right? The arrow. It just means the graph doesn't stop is what they're trying to indicate. Okay, so I saw a couple good answers, and this is good. So phasor, I'm going to be nitpicky because this is what you have to do as a mathematician. You can't say that it has no slope because it absolutely does have a slope, and that slope is 0. So I understand what you're saying when you say it has no slope. I think what you're meaning is the slope is 0, but you have to say that. Yes. If somebody said it has no slope, that to me would suggest it's undefined, just like Queen Bee is saying. As a rule, just don't even say it has no slope. Just don't even use that terminology, I would say, because it's confusing, is what I mean. So if it's horizontal, it's 0. If it's vertical, just like Queen Bee said, we would say this slope is undefined. It's just not a number. And that's all there is to it. So again, I know it sounds nitpicky, but that's the nature of math, So in normal life, I'm pretty laid back. But you can't be in math. You've got to be exact. It's a struggle to be exact. That's part of the challenge. Okay, so just a little bit on slopes. Again, slope is just a measure of steepness. If a line has a slope of 20 versus it has a slope of 1 million, well, 1 million is bigger. That means that line is much more steep. That's really all it means to me intuitively. Okay, so we want to find the equation of a line that satisfies the given conditions. I'll do a couple of these. You tell me if you want to see them all again, my friends. I feel like we're making much better or much faster progress today, but I also think these questions aren't hopefully as bad. Okay, so there's really only two equations that you need to know. You can really get by with knowing just one of them, but it's good to know. You want to know the forms. So you have to know slope-intercept, and that's the one I just put up there. So slope-intercept form. And this is the one, I don't know. It feels like I think people maybe see this one a little more regularly. So that's going to be y equals mx plus b. And again, we said that m is the slope. B is the value of the y-intercept. So if you're given a line in this form, great, you can go ahead and plug it in there. And notice in this question, we are, because we're given that the line goes through 0, 4. And again, I should put x's on all these axes, x and y axes, but sometimes I'm a little lazy. So pay no mind to that. So I know the y-intercept. That's great. I know the b value. So this point on the y-axis, that's the point 0, 4, right? Those are the coordinates of that point. All we care about, though, is the y value. We care about that y-intercept. So here our b value is going to be positive 4. So I already know, well, my formula is going to be y equals mx. The slope, or excuse me, the y-intercept is plus 4, positive 4. So I put a plus 4 there. But we're also even just straight up given the slope, right? We're just straight up given the slope as 5, so there's nothing even to really think about. So that's it. That's the equation of our line, just like Queen Bee said. So, and then just like Queen Bee is saying, the other one you want to know is point slope. And if you know those two forms, slope-intercept and point slope, I think that's about everything you'll ever need to know about formulas for lines. So this is y minus y1 equals m multiplied by the quantity x minus x sub 1. So this is going to be a form of the line. So the line goes through. So I could look at that formula if it had numbers in it and interpret it. So it's a line that goes through the point x sub 1, comma, y sub 1. So one thing I'll kind of point out, suppose this was like positive 4 and this number was positive 5. Notice you would end up with a, y minus 5 and an x minus 4. So it kind of feels like the signs are changing. They're definitely not. Just be careful about that. And you'll see that as we go through our examples. It is something that it's just a little mistake that people make. And again, the same thing, we just need to figure out the slope, either using a formula, counting, whatever. Okie dokie. So again, that's not too bad in this one because in 37, right, we're told that it goes through negative 1, 4, and it has a slope m of negative 9. So if you only remember one formula, right, remember the second one, because that's kind of the, this is really, the second one is kind of, in a sense, the more generic one. The first one's a little more special, right? You know the slope and you know a point, but it's sort of a special point. It's the y-intercept. And on this other formula, it says, well, we still know the slope, but hey, we can just use any old point. So in that sense, to me, right, it's just more general. But again, it's apples and applesauce. It's the same thing. So let's drop in our values. So again, I've got y minus some value equals mx minus some value. So let's put all of our values in there. So it says I've got to plug in y1. Well, y1 is going to be simply equal to 4. So that's what I'm dropping in there, y minus 4. And then it says we've got to drop in the slope. So the slope I already know, that's negative 9. So I can simply drop that right in there. And then I do the same thing. It says we need to drop in our value of x sub 1. Well, that is our value of x sub 1. So I'm going to drop that in right there. Notice I do have an extra negative that I'm going to account for. And that's now going to be, filling in the point slope form. And of course, simplified. So there's not much to do on the left side. We can take a couple steps. Notice we'll have x minus negative 1. We'll give x plus 1. Still not much to do on the right side. To me, at this point, like in my calculus classes, if I said, give me the equation of a line for blah, blah, blah for some reason, I would totally be happy right there. That's fine. Some teachers will want you to sometimes put it in slope-intercept form, which means sort of get rid of the parentheses and get the y by itself. So we could do that real quick. We could distribute the negative 9. We would have negative 9x. Negative 9 plus 1 would be negative 9. We could add 4 to both sides. And that's going to give us y equals negative 9x minus 5. And that looks good to me, barring some sort of little mistake. Alrighty, looking good. So 38, and again, maybe I won't do these all the way out. Maybe I'll give you a little hint or get you started. So here we're told that the line goes through 2, 1, and negative 1, comma 6. So, if I was looking at this problem, I would think, well, again, I'm trying to use one of two formulas, right? Let me even jot them down. For all of these questions, I'm thinking, can I use y equals mx plus b, or is y minus y1 equals mx minus x1? That's kind of my first thing I think is, which one of those two forms is the most appropriate? Well, the first one, again, you need the y-intercept. So to use the first one, you need the y-intercept. And if you don't have it, just don't use it. Well, in this case, I don't have the y-intercept, so I'm going to use the second one. I could either call this first point x1, y1, or I could pick this second point to be x1, y1. It doesn't matter. Just pick one of them. The only thing you don't do is pick an x-coordinate from one and then the y-coordinate from the other. So don't do that, but I don't think many people would do that, unless you did it by accident. And that's totally possible. So I'm going to use this first point, 2, 1, only because both of those numbers are positive. And then when I start substituting things in, it kind of keeps me from making silly sign mistakes. So that's just one of those little math strategies that really has nothing to do about doing mathematics other than having good form. So that's just one little thing for me. Okay, so it says we're going to have y minus the y-coordinate, which is just 1, equals the slope. Okay, I'm going to put a little question mark above that because I don't know the slope just yet. And then I'll plug in x minus the x-coordinate, which we said is going to be equal to 2. So the only thing I need to figure out now is the slope. But again, I can just use my formula, the change in y. So 6 minus 1, so 6 minus 1, over the change in x, negative 1 minus 2. So negative 1 minus 2. So 6 minus 1, that's 5 in the numerator. Negative 1 minus 2, that's negative 3. And again, just to remind you, that's the same thing as negative 5 over 3, or you can pull that nice negative right out front. Does that look like it's out front? We'll put it right there. So all three of those are the same. Just put the negative on there somewhere. Bottom, top, out front. So it simply says the equation of our line is going to be y minus 1 equals the slope, which is negative 5/3 multiplied by x minus 2. And again, I'm just going to stop right there. You could distribute, you could put it in slope-intercept form. But again, hopefully not too bad. How are we doing on this line stuff? Should I do, okay, so 39 is just a little sort of trick question. Well, not really. So I think 39, hopefully, right? That one's not hopefully too bad either. They give you the y-intercept. So I have y equals mx. Again, I'll put a little question mark. The y-intercept, I could put plus. Okay, the y-intercept is -7. We don't write it that way, right? We just write it as -7. Again, now I want to compute the slope in this case. And if you want to see a little picture, right, it says that the x-intercept is over here at 3. The y-intercept is down here at -7. So again, if you wanted to, you could do change in y over change in x. And just like Queen Bee is saying, this is important too. The x-intercept of 3, that means that the coordinates 3, 0 are on there. So thank you. That is worth stressing. And likewise, the y-intercept of -7, that means that the point 0, -7 is also a point on the line. So you could do change in y minus change in x, y2 minus y1 over x2 minus x1. You could also count. I'm just going to count, change in y over change in x. So if I'm at -7 and I go up to, the x-axis, which is y equals 0, that's a change in y of +7. I've moved up 7 floors. And then likewise, if I go from the x-coordinate of 0 over to the x-coordinate of 3, that's going to be a change in x of 3. So again, my slope, it's change in y over change in x minus 7, because we said -7 is the y-intercept. And ooh la la, once again, we have the equation of our line. And I'm spending quite a bit of time on lines because things turn back into lines, okay? So 41 and 42, that has to do with parallel and perpendicular lines. So maybe let's do these real quick, and then we'll get into the other more meaty questions a little bit. I think the last few will get a little more tricky. So it looks like we got about 20 minutes, so we're still doing good. So, okay, so it goes through blah, blah, blah. So it goes through, we said, -1, -2, parallel to 2x plus 3y equals 8, and perpendicular. So here it goes through the point -1/2, 4/5, and is perpendicular to 4x minus 5y equals 10. Okie dokie, sorry. You had to watch me 40, so the slope is 0. Are we saying the slope is 0? No, the slope would be 7 over 3. Let's see, did I do 40? Did I skip 40? Sorry, I may have skipped 40. Oh, yes, sorry, I totally skipped 40. Sorry, I totally overlooked that one. So it goes through 4, 5, thank you, parallel to x-axis. Okay, so this is good. Thank you, Queen Bee. You saved me here. Okay, so it goes through 4, 5, so there's my point, and it's parallel to the x-axis. So it's just a flat line. So just like you said, Queen Bee, yes, the slope for this line would be equal to 0. You're absolutely correct. So what would the equation, okay, yeah, what happened to 40? I think we got it. So here we go. Okay, so yeah, so a horizontal line is going to be a slope of 0. So in this case, what would the equation of that line be? So we have y equals mx plus b. So the slope is 0. Again, what's our b value in this case? Well, our b value is going to be the y-intercept, but if it's horizontal, and if it goes through 4, 5, well, the y-intercept is just going to be plus 5. So it says the equation of our line is going to be y equals 5. That's how we simply describe a horizontal line. Again, I would say if there is a common mistake, People will describe that line by saying it's like x equals sometimes 4 or 5. They'll do something like that. They'll pick something, and I think the reason why they do that is because they see x-axis, and it's parallel to the x-axis, so they have that x sort of stuck in their brain, you know what I mean? So don't do that. This to me says put a dot everywhere there is a y-coordinate of 5. Well, if you put a dot everywhere there's a y-coordinate of 5, it doesn't matter what the x value is, so eventually you're going to fill in that horizontal line. Hey, Sophia. Yeah, my pleasure. So thanks for stopping by, and thanks for the kind words. I appreciate it. So I hope you're well. So likewise, while we're at it, let's go ahead and do this as well. Let's use the same point. So this is the one that's parallel to the x-axis. Suppose it went through that same point, 4, 5, but it was parallel to the y-axis instead. How would I describe that line? So suppose instead of going left to right, suppose my line is going straight up or down. It's supposed to be vertical. How would I describe that line? So we said this is y equals 5. How would we describe the line that's vertical? And I think, well, I'm drawing a line where all of the x-coordinates are equal to 4, and that's exactly how we describe a vertical line. So that vertical line, that vertical line that is parallel to the y-axis, we would say that would be the line x equals 4. So yes, everybody's got it. So be careful about that, because I think a lot of times we're so used to seeing lines that have both the slope and the y-intercept, like this example, y equals 7/3 x minus 7. And then sometimes when people just see like, you know, these like y equals 5 or x equals 4, sometimes they kind of forget, oh, hey, those are actually lines too. And what lines are they? Oh, it's horizontal or vertical. So just a common little thing to have issues with. Okay, let's go back to parallel. Parallel. So if two lines are parallel, what do we say about their slope? Right, so if two lines are parallel, they never cross. And if two lines are parallel and they never cross, that means they're going to have the, they're simply going to have the same slope. Right, so two lines have the same slope. So I want a line that goes through the point -1, -2. So I'm going to use this formula, y minus y1 equals the slope, x minus x1. So I think, well, this could be my x1 and this could be my y1. So I already have those values. Yeah, exactly, Phaser. They're the same if they're parallel. That's exactly correct. So if, and this is the problem with the delay in this video, I apologize. Like I'm asking a question, but there's like a 10-second delay, so I ended up just answering it because I guess it'll take forever. So, okay, my apologies. So I've got a point. The only thing I'm missing is the slope. Well, how would I get the slope of this line 2x plus 3y equals 8? I need to figure out the slope of that line. And then once I have the slope of that line, I can just drop it in, again, because they're the same. Well, there's different ways we could do it. One way we could go about doing that is we could just, manipulate that equation so that we have the y by itself and we have it in this form, y equals mx plus b. And then we can read off the slope, and then we can plug it in, and then we've got our equation. So that's the idea. So we just want slope from this line. I want to know the slope. So I'll put in to form y equals mx plus b, and then I'll be able to read off the slope. Okay, so that's my goal here. So yeah, I think you're probably right there, Queen Bee. So I'm going to subtract 2x from both sides. And I'm going to rewrite the right side before I do anything. I'm going to write that as -2x plus 8. And exactly, if I divide the left side by 3, I have to divide the right side by 3, so everything. On the left, the 3's cancel out. I could break up this fraction as negative 2/3 x plus 8 over 3. That 8 over 3 I don't really care about at all. The only thing I'm really interested in is that slope. Just like we said, that's equal to negative 2/3. So I think now we're in business. So I can say, hey, my line is y minus the y coordinate, which was negative 2. So if I do y minus negative 2, that's just going to be y plus 2. I can now drop in my slope, which we just found, of negative 2/3. And then I would do the same thing. I would do x minus the x coordinate. Well, the x coordinate was negative 1. So if I do x minus negative 1, that's going to be the same thing as x plus 1. And again, I'm going to stop there. That to me is an equation of a line. If you want to multiply it out, put it in slope-intercept form, by all means, go for it. Excuse me. Okay, so the only thing that's different about 42, right? Almost the same question. So in 42, you're given a point. Yeah, you got fractions. Okay, who cares though? You've got a point, yes. And I've got a line, yes. But now I need the slope to be perpendicular. And if two lines are perpendicular, what does that mean? So parallel, we said they never cross. Never cross. Yeah, things get, I think we had the same experience there, not. So you're in good company. You're in good company. You're seeing the result now of many used hours. Okay, so if they're perpendicular, what is the relationship between the two lines? Well, they cross, but they also cross in a special way, right? You can't just say they cross because, you know, those two lines cross, but they're not perpendicular. Recall that if they cross at a right angle. Okay? They cross at a 90-degree angle, not a 45-degree angle. They cross at a 90-degree angle. That is perpendicular. So what's the relationship? Suppose a line has slope, I'm going to say m equals 7 over 3. A parallel slope is also going to be, well, sometimes you'll see a little symbol like that. Again, it sort of indicates parallel. The parallel slope would be the same. And if we went perpendicular, exactly, Queen B, a perpendicular slope, we say oftentimes, you can say negative reciprocal. I'm going to say the opposite just because that's how I always heard it. I understand what you're saying by saying the negative. If you take the negative of something, you do make the opposite of it. But I don't like negative because sometimes I've had people feel like there needs to be a negative sign somewhere in the slope. So I know you understand it completely, but again, it's just one of those things I'm going to be anal about. Okay. A perpendicular slope is the opposite reciprocal. So in this case, a perpendicular slope, it says you change the sign. Well, I started with a positive 7 over 3, so I know I need a negative. And then you just flip the fraction, 3 over 7. And that's going to be the notion of a perpendicular slope. So maybe I'll skip 42. So again, in 42, we're given the point, right? Negative 1/2, 4/5, and then we're given this line. But to get the slope of this line, we can do the exact same thing that we did a second ago, right? We can just put it in slope-intercept form. Oh, heck, let's just do it. I always do this. So let's put it in slope-intercept form. Oh, my goodness. I'm going to do two things at once. I'm going to add the 5y to both sides just to make it positive. And then I'm going to subtract the 10 over to the left side. So if you want to take 2 steps, go for it. Hey, Brian. Happy to help you. I'm glad I could Save your bacon. You can come correct my algebra mistakes. Okay, so I'm adding 5y to both sides, and I am subtracting 10 from both sides. And now I'm going to do is just divide both sides by 5. By 5, by 5. That's going to be 4x over 5 minus 10 over 5, which is 2. I could write that as 4 over 5x minus 2. Now that's the slope of this line. So the perpendicular line is going to have slope. Well, the original line has slope 4/5. Change the sign. It's negative. Flip it, 5/4. So obviously, if it was negative at the beginning, flip it, make it positive. Okay. And then you just do the same thing. You've got the point. Just be careful with your algebra. We've got a few minutes left. Do you guys want to do 43 and 44? I say guys in the the all-inclusive sense here. Do you guys want to go ahead and jump on? The next ones start into factoring, and they're pretty similar, the next two. Should I do those real quick and then we call it a day, or have you had enough? And I can just pick this up here tomorrow, and then we can do domains. I think I should be able to get through all the domains next time. I'll probably do the same thing tomorrow 5 p.m. I'm going to keep trucking until I get through these, I guess. I cannot do Wednesday, not Wednesday. I have obligations that evening, so we'll have to skip a night. Let's go. Okay, let's keep going. Okay, let's go on or let's stop. I'm going to go on. We've got a couple minutes, and I'll be fast, I promise. Okay, so when I want to factor something, I'm looking for terms, right? And those are separated by pluses and minuses. So even though I see a plus here, okay, yeah, there's two terms in the parentheses, but I see, since there's multiplication between the x squared and that set of parentheses, to me I see that as all glued together. That is one term. And I do that with my other one as well. So there's my plus sign, and it kind of breaks those into two pieces, two terms. And what I do is I look at each one of those terms and I think, what variable is in common? Or what stuff in parentheses is in common? So in this case, well, I notice, hey, I've got an x to the second power, and I've got an x to the third power. That's good. That means I can factor out a power of x. Now notice I also have x plus 1 in parentheses to a power. Hey, I've also got x plus 1 in parentheses. So I've got the same thing. So in this case, and basically the idea is you just factor out the smaller power. And eventually, like in calculus, you end up with negative powers, -2, x to the -2, and x to the -10. Factor out x to the -10 because that's the smaller power. So keep that in mind. So in this case, if I look at x squared and x to the third, x squared is the smaller power. And if I look at x plus 1 to the fourth and x plus 1 squared, well, x plus 1, again, to the second power is the smaller power. And that's sort of everything that was in common between the two. And then I think, okay, what goes in the parentheses? However many terms you started with, we started with two terms, a factor, a plus sign, and a bunch of stuff being multiplied into factor. You're going to have two terms in the parentheses. Well, x squared times what is x squared? Well, x squared times 1 is x squared. So I'm just going to leave that out because I don't think we'll need it. Well, x plus 1 squared multiplied by what is x plus 1 to the fourth power? Well, I think I would need another x plus 1 quantity squared. And notice when I distribute the stuff I factored out to that first term, the only thing that's going to change is that exponent on the x plus 1 squared, and it's going to end up giving me the correct exponent. So yay. So that is that part. And then for the next one, okay, I think x squared multiplied by what is x to the third. Well, I need to multiply that by x. And then x plus 1 squared multiplied by what is x plus 1 squared? Well, just times 1. So I'm just going to write that as plus x. And that is now factored. Okay. You could simplify, say, inside the parentheses if you want. I definitely, as a rule of thumb, if you factor stuff, like for example, don't multiply this out. Because if you multiply it out, you're unfactoring. You want to keep things as a product. So just leave that alone. This stuff inside the brackets, I think I would simplify. So quickly, x plus 1 times x plus 1, that's going to be x squared plus x, which is plus 2x, plus 1 times 1, which is going to be plus 1. So remember, if you just square this out, that's going to give me that part. And then I still have my plus x hanging out. And if I simplify, that's x squared multiplied by x plus 1, quantity squared. I'm going to have x squared, it looks like plus 3x plus 1. And that is now beautiful. That looks good to me. That is nice and factored. This is something, again, if you are going on to calculus, you will be doing this procedure and a whole lot of problems. You'll be doing it all the time. And it's a place that I see people having issues. We'll jump on to, let's do 44 next time. So we'll pick up 44 next time. Let's do, so the next session tomorrow, we'll just do the same thing tomorrow at 5 p.m. Hopefully people can make it. Wednesday I'll have to skip. Thursday we'll see. I may be running around. So I may even wait till the weekend to do after tomorrow. We'll see. You all tell me how your schedule is. And yes, Brian, of course you know 0.99 repeating is certainly equal to 1. So, okay, I hope that helps everybody. I know we went a little quicker, which is good, but it's also can be bad because it's fast. But you all seem, at least the people that are responding, seem to be right on top of things. So that's why I did move a little faster. And definitely, if you want to, jot down questions as we go. Always be able to... or jot down questions. Try to work on them. If you get stuck, we'll try to do them. Sorry, Phaser, you can't make it tomorrow. That you got an appointment at 3 p.m. Yeah, that will be obviously 5 my time. So this should, I think all of these are getting saved, so you can always go back and watch it. I know it's kind of yeah, you have a good evening too, Brian. Thanks, man. Thanks for coming. So I know it's not quite the same as being here, you know, watching a live stream. I watch chess live streams that have been recorded, and there's something different about watching it as it's live, for sure. So I understand that. But c'est la vie. But anyways, okay, my friends, I'm almost positive I'll do it tomorrow. If not, I will let you know, and you can always just stay tuned. So, all right, my friends, have a good evening. I think that's it for me now. You'll be happy to know that it's the nice warm evening in Austin, and I'm going to the pool. So I'm going to have, hopefully, a good evening. So I hope the rest of you all have a good evening too. I'm going to go listen to music, swim, read a book, and enjoy this nice summer weather. So peace out, friends. Cheers. I hope you have a good evening, and I'll hopefully see you tomorrow. Phaser, sorry I won't see you, and I hope to see you sooner than later. So, all right, my friends, have a good night. Take care.